to True Projects. In this video, we are going to explain about the project, which is time-aware attention-based gated network for credit card fraud detection by extracting transactional behaviors. Introduction of the project. With credit cards being widely used globally, the timely and accurate detection of fraud has become crucial to safeguard user accounts. Ensuring the security of these financial transactions is paramount in maintaining trust and confidence among users. The scale of credit card fraud is evident in the substantial global losses reaching approximately 28.5, which is 65 billion in 2019 and escalating to 35 billion in 2020. These staggering figures underscore the urgent need for more effective fraud detection measures to mitigate financial losses on a global scale. Traditional fraud detection systems often rely on original transaction features that inadequately capture the dynamic and evolving nature of transactional behaviors. This limitation results in suboptimal accuracy in identifying fraudulent activities, necessitating innovative approaches to improve the overall effectiveness of fraud detection. The project takes a proactive approach by enhancing representation of transactional behaviors through novel aggregation strategies. This includes incorporating periodic behavior analysis, aiming to address the shortcomings of using original features and ultimately improving the accuracy of fraud detection models. Recognizing the challenges in learning from long sequences, the project integrates advanced RNN variants such as LSTM, BiRNN, and GRU. This integration aims to enhance the model's ability to capture temporal dependencies, leading to improved pattern recognition and more effective approach to detect fraudulent activities in credit card transactions. Objective of the project. The primary objective of this project is to develop a credit card fraud detection model that adeptly extracts transactional behaviors from historical transaction records. Emphasis is placed on capturing both long and short-term transactional habits to create a more nuanced and comprehensive representation of user behaviors. The model seeks to overcome the limitations of existing studies by incorporating changes in transactional behaviors resulting from different time intervals. This approach ensures a more dynamic and responsive fraud detection system that adapts to evolving patterns of fraudulent activities over time. The project aims to enhance the credit card fraud detection performance through the implementation of a time-aware attention-based gated network. This sophisticated network architecture is designed to learn new behavioral representations from consecutive historical transactions, improving the model's ability to discern subtle patterns indicative of fraudulent behavior. The ultimate goal of this project is to contribute to the reduction of credit card fraud by implementing an advanced fraud detection model by effectively identifying and mitigating unauthorized transactions. The project seeks to safeguard cardholders' accounts, ensuring the security and integrity of financial transactions. The project leverages state-of-the-art algorithms such as long short-term memory, bidirectional recurrent neural network, and gated recurrent neural network to model temporal dependencies in transactional data. Additionally, the implementation of a time-aware attention mechanism enhances the model's ability to capture critical features across various time intervals, further improving its accuracy in detecting fraudulent activities. To implement this project, we need software and hardware requirements. Hardware requirements are operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, front-end technologies of HTML, CSS, JavaScript, and Bootstrap 4. We have designed various steps in the flow of work to execute the project. The first step is importing the packages. Essential Python packages and libraries are imported in this step. We have imported NumPy and Pandas for data manipulation, Seaborn and Matplotlib for visualization, scikit-learn for machine learning, TensorFlow for deep learning, and Flask and SQLite for web development. The next module is exploring the dataset, which is credit card dataset. The dataset containing the information of credit card is loaded and an initial exploration is conducted to understand its structure, dimensions, and data types. This step is crucial for gaining insights into the dataset before further analysis. Coming to data processing, here we have two substeps, which is Pandas data frame and dropping unwanted columns. Coming to Pandas data frame, Pandas data frame is created to facilitate efficient data manipulation and analysis. Coming to dropping unwanted columns, columns that do not contribute to the analysis or modeling process are removed, streamlining the dataset for better performance. Visualization using Seaborn and Matplotlib. Data visualization techniques leveraging Seaborn and Matplotlib are applied to create informative charts and plots. These visuals aid in understanding data distribution, patterns, and potential relationships. Label encoding using label encoder. Categorical variables within the dataset are encoded into numerical format using label encoding in this step. This pre-processing step is essential for machine learning algorithms that require numerical input. Coming to feature selection, the feature selection method, which is select percentile, is employed to identify and retain the most relevant features for machine learning model. This helps in improving the model's efficiency and performance. Splitting the data into X and Y. The dataset is divided into two components, which are input features as X and the target variable as Y. This separation is crucial for training the machine learning model. Coming to building the model, this involves constructing a machine learning model for predicting credit card fraud. Training and building the model. The model is trained on the training dataset, allowing it to understand the underlying patterns in the data. This training phase is the critical step in preparing the model for accurate predictions. As an extension, we applied ensemble method combining the predictions of multiple individual models to produce a more robust and accurate final prediction. As an extension, we built the front-end using Flask framework for user testing with user authentication. Coming to Flask framework with SQLite for sign-up and sign-in. The Flask framework is employed to set up a web application. SQLite is used for user authentication, enabling users to sign in and sign up into the system. Next step is importing the packages. The next step is user gives input as feature values. User provide input features via the web interface to receive predictions. The given input is pre-processed for prediction. The user provided input is pre-processed to align with the format expected by the machine learning model. The next step is train model is used for prediction. The pre-processed input is fed into the trained machine learning model to make predictions based on the learned patterns. The last module, which is final outcome, is displayed through frontend. The prediction outcome is presented to the user through the frontend of the web application, providing the final result of the credit card fraud detection. Algorithms which are used in this project are HAINT LSTM, which means Historical Attention Integrated LSTM. It is a variant of long short-term memory neural network. It integrates a historical attention mechanism to consider the frequency of past occurrences. This attention mechanism enhances the model's ability to capture long-term dependencies in the sequential data. It is employed to address the challenge of learning from long sequences in transactional data. Its historical attention mechanism allows the model to focus on relevant patterns over time, crucial for detecting fraudulent activities with extended temporal dependencies. The next algorithm is time attention hetero-RNN. It is a type of recurrent neural network that incorporates attention mechanisms. It allows the model to assign varying importance to different elements of the input sequence with a specific focus on time-related features. This algorithm is chosen to capture temporal patterns in credit card transactions. The attention mechanism helps the model prioritize certain time-related features, providing a more nuanced understanding of transactional behavior over time. Coming to attention NN, which means attention neural network. It is a neural network architecture that includes attention mechanisms. Attention mechanisms enable the model to focus on specific parts of the input sequence, enhancing the ability to learn intricate patterns. It is used to improve the model's ability to discern relative features within the dataset. Attention mechanisms are beneficial for credit card fraud detection as they allow the model to focus on critical transactional behaviors. Coming to LSTM, which is long short-term memory, it is a type of recurrent neural network designed to overcome the vanishing gradient problem. It includes memory cells and gating units, enabling it to capture long-term dependencies in the sequential data. It is a fundamental choice of modeling sequential data in credit card transactions. Its ability to capture long-term dependencies is crucial for understanding patterns indicative of fraudulent activities. GRU is Gated Recurrent Unit. It is another type of recurrent neural network similar to LSTM, but with a simpler structure. This includes gating units to control information flow, making it computationally more efficient. It is chosen for its efficiency and effectiveness in capturing sequential patterns. It provides a balance between computational complexity and performance, making it suitable for credit card fraud detection. Coming to BiRNN, which is bidirectional recurrent neural network. Bidirectional recurrent neural network process input sequences in both forward and backward directions, capturing information from past and future context. It is employed to ensure that the model considers information from both past and future transactions. This bidirectional processing enhances the model's understanding of transactional behaviors. Coming to gated RNN, which is gated recurrent neural network. It is general term of recurrent neural network that include gating mechanisms. Gating units control the flow of information, allowing the model to selectively retain or discard the information. It is used for its ability to handle sequential data effectively. The gating mechanism helps in capturing relevant patterns in the credit card transactions. Coming to time LSTM, which is temporal LSTM, it is a variant of LSTM that includes design time gates. These gates enable the model to explicitly consider the temporal aspects of the input sequence. It is selected to this model user sequential actions in credit card transactions. The design time gates helps capturing users' interest over different time intervals, contributing to more accurate fraud detection. We have evaluated this project using different error metrics of the classification, which is accuracy, precision, recall, and F1 score. Here we have comparison graphs of this project. This is the accuracy score comparison graph. Accuracy is a metric used to measure the overall correctness of a classification model. It is defined as the ratio of correctly predicted instances to the total number of instances in the dataset. Here on x-axis we have accuracy scores and on y-axis we have algorithm names. Coming to precision score, it is a metric that quantifies the accuracy of positive predictions made by a model. It is defined as the ratio of true positive predictions to the total positive predictions. Here also on x-axis we have precision score for each algorithm and on y-axis we have algorithm names. This is the recall score comparison graph. Here on x-axis we have recall score for each algorithm and on y-axis we have algorithm names. Recall is also known as sensitivity or true positive rate. It measures the model's ability to correctly identify all relevant instances in the dataset. It is defined as the ratio of true positive predictions to the total positive, which is actual positive instances. This is F1 score comparison graph. Here on x-axis we have F1 score for each algorithm and on y-axis we have algorithm names. F1 score is a metric that combines both precision and recall into a single value, providing a balance between them. It is a harmonic mean of precision and recall, and it is particularly useful when we want to strike a balance between minimizing false positives and false negatives. To execute the project, first we need to open the code folder which contains source code files. So this is the code folder of the project. This is the static folder. This folder consists of files related to CSS, JavaScript and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is the app.py file. This .py file contains information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content that to be rendered in the HTML templates. Here we have credit card dataset that we use for training the algorithms. This is the notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the datasets. This is the signup.db file. This file is a database file used to store the user information. These are the model files. These files contain the algorithm information which will be loaded into the project code during runtime. To execute the project, we need to copy the path of the address bar from the file explorer. So I'm copying the path. Now we need to open the Anaconda prompt. Using the cd command, followed by the space, we need to paste the copied path and then click on enter. Using this command, the current directory will change to the code folder's path. So here we can see that current directory is changed to the code folder's path. Here we need to type the command python space app.py and click on enter. This will compile app.py file. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, which is the localhost. This is the localhost and the port, unless configured differently. Now we need to copy this local link provided by the framework and paste it in any web browser. So I'm copying the link. I prefer Google Chrome, so I'll paste it in that. Here we need to paste the link and then click on enter. This is the web page of the project which is displayed in the browser, and this web page is built by using the Flask framework. Here we can see a sign up link. First we need to click on it and enter all the sign up details if we are signing up. I have already signed up and I have an account in it, so I'll directly click on sign in. Here we need to provide our username and the password to log in. So I'm giving my username and the password, and now we need to click on login. We have logged in successfully. Here we can see some of the parameters which need to be entered. Based on the given parameters, we will get the prediction whether the credit card fraud has been detected or not. So these are the variables named as V3, V4, and these are the features in the dataset commonly used to predict privacy of individuals and organizations associated with the sensitive information such as credit card transactions. The generic labels replace actual variable names to reduce the risk of accidental exposure and unauthorized access to specific details. So now we will enter all these details. So V3 value is 2.536, V4 value is 1.378, V7 is 0.239, V9 is 0.090, and the V10 value is 0.90, and the V11 value is minus 0.551, V12 value is minus 0.6178, V14 is minus 0.3117, V16 is minus 0.4704, and the V17 is 0.207, V18 is 0.025. Now we will click on predict. So based on the given input, it is predicted that non-fraudulent transaction happened based on the ML, which means there is no credit card fraud detected. Now we will enter one more parameters. So the V3 value is minus 18.6499, V4 is 9.5059, V7 is minus 16.0716, V10 value is minus 8.507, V11 value is minus 14.1102, V12 is 5.299, V14 is minus 10.834, V16 is minus 9.37, V17 is minus 9.899, V17 is minus 9.6, V18 is minus 19.236. Now we need to click on predict. So here it is predicted that fraudulent transaction happened based on the ML for its given input, which means the credit card fraud is detected. In this way, if we enter the given parameters, we will get the prediction whether the credit fraud is detected or not. Conclusion of the project. The project employs advanced algorithms like Hind LSTM, time attention, hetero-RNN, and attention NN, enhancing credit card fraud detection accuracy. Attention mechanisms and historical behavior considerations contribute to improved sensitivity to fraud patterns. Algorithms such as LSTM, GRU, ByRNN, and LSTM adeptly capture temporal dynamics in credit card fraud detection. The model excels in discerning both short and long-term dependencies, offering a comprehensive understanding of evolving transaction behaviors. Innovative feature selection and representation strategies include attention mechanisms and time gates, yield a feature-rich portrayal of transactional behaviors. This nonce representation empowers the model to integrate intricate patterns critical for fraud detection. Integration of the Flash framework with SQLite enables a user-friendly interface for sign-up and sign-in and real-time predictions. Beyond model training, the project aims to reduce credit card fraud, prioritizing user account protection and fostering a secure.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.